Welcome back. Let's do some more examples using the multiplication principle. Okay, for example 4, we have the word Kelowna, which has 7 different letters in it, Kelowna. And my question is, how many ways are there for me to make an arrangement out of 4 letters? So first off, when I say an arrangement, we're talking about putting things in some kind of an order. So when I say arrangement, something like KELO would not be the same thing as OLEK. These are two different arrangements. Even though it's the same letters, the order that they're in is different from each other. So when I'm thinking about the tasks that I'm going to be doing, I'm going to be filling in the 4 positions. So I have my first position, the one the furthest left, and then my second position, the one that's second from the left, and then third from the left, and fourth from the left. So I'll need to be filling in my 4 different positions. And now let's start with the first part. The question for the first part is that we're not restricted to how many times I can use a particular letter. So I could have my arrangement be K, 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 for example, or L, 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 W. That would be a totally valid arrangement for this. So when I'm filling in my 4 positions, working my way from the farthest left to the right, I would say, well, for my first position, there would be 7 choices of letter. And if I'm allowed to repeat that, then there should be 7 choices again for the second position. And when I'm third for the right, there's still 7 choices and still 7 choices. So it looks like there should be 7 to the power of 4, or 2,401 ways to make an arrangement of 4 letters involving K's, E's, L's, O's, W's, N's, and A's. Of course, now we want to think about some restrictions on this. So again, reminder, this first number that we found, the 2,401, that was the no restrictions. That was essentially the universe for all the possible arrangements. So once we start putting on restrictions, we should be getting numbers that are smaller than this. If I manage to have a question like a part B or a part C where suddenly I have more than these 2,401 options, that's a good sign that I've done something wrong. Okay, so no letter can be repeated and no real specifics as to which position is important here, so I don't need to change the order up. I can still fill things in from left to right, going first, second, third, and fourth. Just now, this time, I'm going to have to keep track of how many letters I've used. So I begin with 7 letters and the furthest left position. So I've plopped in a letter there. And now since I'm not allowed to repeat a letter, then I don't have 7 choices anymore. I've only got 6. And again, same thing. Once I've used that first 2 positions, I've used 2 out of my 7 letters. There'll only be 5 choices, and then finally 4 choices for that last position. So we should have 7 times 6 times 5 times 4. We should have 840 possible options. Part C, we add an extra restriction. So we're still not repeating any letters. Just now we're throwing on an extra restriction where the first position and the last one have to be a vowel. Just to note here, because there's always a question about this, who is considered a vowel? For this course, when I'm referring to vowels, I'm only referring to A, E, I, O, and U. I know that W and Y, they sometimes act as vowels, but we're not counting them as vowels here. So as far as the vowel options go, in this word, Kelowna, there are only 3, the E, the O, and the A. Now, since the restriction has to deal with the beginning and the end, then it makes sense for me to deal with those restrictions first. So instead of filling things in first, second, third, fourth positions, working my way from left to right, I'll fill in the first position, then I'll do the fourth position. I'll do the beginning and the end first. And then once I've done the beginning and the end, then I can just fill in the middle any old how. So I want it to begin with a vowel. And to begin with a vowel, there would be 3 choices, the E, the O, or the A. And then to end with a vowel, I'll only have two vowels left to choose from because I already used one up at the beginning. So I've taken one out of the three vowels, put it at the start. I've taken one of the other remaining vowels, put it at the end. And now I just need to fill in the two middle spots. And for the two middle spots, they can be whatever. It doesn't really matter, vowel or consonant. I just can't repeat things. So the first two letters that I've used, they have been used up. So there's only 5 things remaining. So I'll have 5 choices for position 2. And then once I've slotted something in there, then I'll only have 4 choices for the third position. So we kind of had to go beginning, end, and then filling in the middle. And that was because our restriction had to do with what's going on at the beginning and the end. Anyhow, we multiply and we find that there are 120 possible options. Okay, one more example to look at. We have an example involving selecting shoes. So in this closet, 5 different pairs of shoes and visually different. They don't match each other. They're all different colors. I've got a pair of red shoes, a pair of black ones, an orange pair, a green pair, and a blue pair. So if you walked into this closet and picked 2 shoes out at random, it's possible that you might get 2 that don't match. And we want to know, how many ways could you do that? How many ways could you select a shoe that pair that doesn't match? So for this one, there's the obvious that there's really 2 tasks that you need to complete. You need to select a left shoe and you need to select a right shoe. And of course, you could do it the other way around, right shoe first, left shoe afterwards, either way. And we want to make sure that when we do our selection, we get a pair that doesn't match. So at the beginning, when I don't have any shoes on my feet whatsoever, for left shoes, there are 5 of them. So I have 5 choices of what shoe I could put on my left foot. And then once I've picked a particular color, whether it's the red one or the orange one, doesn't really matter, I can't use that same color for my right foot. So I don't have 5 choices for my right shoe. I'll only have 4 choices. So it looks like there should be 20 possibilities. Now, I did want to tackle this question a second time. I mentioned before in a previous question that we could have tackled things using instead of using just the multiplication principle, we could have used counting the complement. And this is another example of one where you could have a second way to tackle the same problem. If I'm thinking about this question, I'm looking for the number of ways I can get shoes that don't match. So that's what I'm looking to count, the number of ways to get unmatched pairs of shoes. And the counting the complement idea says, well, that should just be the number of things inside the universe minus the complement, the opposite of shoes that don't match, which would be shoes that do match. So if I take the universe, all the options, and get rid of the ones where the shoes match, then I should be left with the shoes that don't match. Now, as far as the universe goes, it's easy enough to count that. You have 2 things to do. Select a left shoe, select a right shoe, and if you didn't put any restrictions on it, which we don't when we're counting the universe, there'd be 5 choices for your left shoe and 5 choices for your right shoe. So in other words, there's 25 ways to pick 2 shoes. And if we're thinking about how many ways are there to pick shoes that match, the answer's right there in the question. There are 5 different pairs that match. There's a red pair, there's a black pair, an orange, a green, and a blue pair. So if we're thinking about this problem, I could have done it this way. I could have said, instead of using just the multiplication principle and keeping track of the shoes that have been already used up, I could have used the complement and said, to find the shoes that don't match, take all the pairs and remove the matching ones. There are 25 pairs. There are 5 that match, and so that means there are 20 unmatched pairs. All right, one last example. So this is toughest one saved for last, example 6. In this one, Fiona has 4 different textbooks that each come with a solution manual. So we'll have a textbook A and a solution manual for A, a B and a solution manual for B, and same thing for textbook C. We could imagine that these are maybe different topics or different courses, but there we go. We've got these pairs of things, these solution manual and textbook pairs. The question is, we want to take these 1, 2, 3, 4, 5, 6, 7, 8 things and put them on a shelf, but we've got a bunch of restrictions. And so the restrictions are that the textbook and the solution manual need to be next to each other. So I would not be able to have textbook A, textbook B, and then solution manual for A. That would not be allowed. So I would be able to have A next to A's solution or A's solution next to A. That would be allowed. So if I'm thinking about this, I know that overall, however I manage to put my books on the shelf, there's going to be 8 books in a row. And that the first 2 will belong to one topic. It'll either be a solution and its textbook, or the textbook and its solution for one of the topics. The next 2 will be another one of the topics. The next 2 will be another one of the topics. And then the last 2 books will be the last of the 2 topics. So my idea for this would be to, again, think about the fact that we actually have a whole bunch of different tasks for us to complete. I'm going to need to decide for myself, for the first pair, who is the topic? Is it book A and solution? Is it B and the solution? Is it C and the solution? Is it D and the solution? So I'll have to decide which of the 4 topics it is, and then I'll also need to decide what order do the books go in. Is it A followed by its solution, or is it the solution followed by A? So this is the idea that I'm going to be working with here. I'm going to say that we've actually got a bunch of different tasks. The first task is which one is going to be the first topic or first course. So is it A's, B's, C's, or D's? And then what order does that first topic go in? Is it textbook followed by solution, or is it solution followed by textbook? And then I'm just going to have to repeat the process. There'll be the second topic, second from the right. Which of the 4 topics is it? And then what order does it go in? And then there'll be the third topic. And I'll put those 2 books in some sort of an order. And then there'll be a fourth topic. And those last 2 books, they'll need to be put in some sort of an order. So when I'm beginning at the very start of things, I have 1, 2, 3, 4 different topics. Topics A, B, C, and D. And I've got the solution manual and textbook for those A, B, C, and D. So 4 topics to begin with. So I might begin with C and its solution. And then once I've decided that topic's coming first, then I'll need to now put those books in some kind of an order. C followed by its solution, or solution followed by C. So there'll be 2 choices. Now I've dealt with the first 2 books on the shelf, which means I don't have 4 topics left to choose from. I've only got 3 topics remaining, so maybe the next 2 books on the shelf might be topic D. And then again, put those 2 books in some sort of an order, either textbook followed by solution or solution followed by textbook. Then we've got 2 topics left, so maybe it's A that comes next. Put those books in some sort of an order. And then maybe the last one, well, I guess you don't really have a choice. There's only one option of what would be left. Those 2 books, though, still have 2 possible orders that they could be placed into. So 4 times 2 times 3 times 2 times 2 times 2 times 1 times 2, there's 384 possibilities. Now, one thing I do want to mention before we leave this question, and that's this sort of an idea of arranging things where we're supposed to keep some items next to each other. We're going to revisit this idea, actually, when we get to section 3.6, where we're going to look at more complicated counting questions. We're going to look at some other ways we could have tackled this question. But to get there, we're going to need some more tools. And those are the tools that we're going to learn in the next section: the factorials, combinations, and permutations.